students, in today's class we are going to see about major landforms of the earth. In yesterday's class we have seen about the internal movement of the earth. That is, recap means internal movement of the earth has been divided into two categories. One is endogenic and another one is exogenic.
Slow movements. Some changes in the Earth's crust are so slow that it takes hundreds of years to become noticeable. They are called slow movements. Slow movements are further classified into vertical movements, horizontal movements. The vertical movements operate vertically in the Earth's crust. They cause large-scale upliftment or subsidence of a part of the Earth's crust. These movements are often known as continent-building movements. Horizontal movements are those movements which operate on the Earth's surface horizontally. Horizontal movements are of two types, that is, forces of compression, forces of tension. Forces of compression. These forces act on the rock strata from opposite directions, due to which the rock layers are bent up or folded into a series of anticlines and synclines. These forces are responsible for the formation of fold mountains. The Himalayas, the Rockies, the Andes and the Alps mountains have been formed due to the forces of compression and are examples of fold mountains. Forces of tension. These forces operate in opposite directions, thus causing a fault or a fracture in the Earth's crust. The fractured rock strata either slide upward or downward along the fault line. The faulting then gives birth to new relief features like the Rift Valley or a block mountain. If a block of land subsides between two parallel faults, then it looks like a huge mountain, known as block mountain. The valley of Narmada and Tapi are examples of rift valleys, while Vindhyas and Satpura are the examples of block mountains.
Endogenic, which means the happening of the earth inside the earth, happenings which happens inside the earth. And coming to exogenic, which the happenings has been happening outside the earth, is known as exogenic process. Now we are going to see about the exogenic process, that is rivers. How that rivers has been occurring. Erosional landform on mountains. In erosional landform on mountains, the first thing is about waterfalls. How waterfalls has been made? Through the means of the flow of the river. It may be in the form of, based on the height, it has been flowing out. It's known as, then only the waterfall has been made up of. Next, coming to on plains, it is of two types. One is meander and another one is oxbow lake. Meander, which means, for example, the river will be flowing like this in a straight manner. It is not possible in the case of meander, because meander will follow, it will not be in straight. It will be in the form of, like, ups and downs will be possible, like a snake. So it is known as meander. Say students, it is known as meander. The meanders will not be in a flow, that is in a straight line, it will be in an horizontal way, that is for example like a snake. The shape will be like a snake. Next we comes to oxbow lake. Oxbow lake, which means when the meander has been flowing like a river, it has been separated due to some of the eruptions or erosions taken place at the edge of the seashores. So it will contains, it will be separated into a small entity or a pond-like structure. So it is known as oxbow lake. It is known as oxbow lake. Once again come again. On the plains, it has been divided into two categories. One is meander and another one is oxbow lake. Meander, which means the river will not flow in a plain manner. It will just be in the form of horizontal way that will be increase or decrease. It will be similar to the snake. So it is a meander. And then oxbow lake, which means it has a small entity which has been separated from the meander, is known as oxbow lake. Next, coming to deposit of landform. In deposit of landform, it has been, the first thing is about the delta. The delta, which means the landform, the mouth of the river flow into the ocean. The river will flow into the oceans, seas, etc. The best example for delta is Ganga Brahmaputra river, because both of them as a combination. And then the square feet is that 1,05,000 square feet has been in common.
So let's start with a question. How does this giant angular boulder end up jammed in among these pine trees in Yellowstone National Park?
To find an answer, we need to learn about some of the characteristic landforms left behind as a result of glacial erosion and deposition.
A glacier is a long-lasting mass of slow-moving ice and snow. See our Classifying Glaciers video for more about the different types of glaciers.
Just like streams, moving ice can be an agent for erosion and deposition. And just like streams, glaciers erode material from near their source, transport rock and sediment downslope, and deposit much of that material where they end.
In areas with present-day glaciers, erosion forms steep-walled, bowl-shaped depressions known as cirques at the head of valley glaciers.
Adjacent glacial valleys are typically separated by sharp, knife-edge ridges known as arêtes.
Glacial erosion can occur where ice is in contact with rocks.
Who among us hasn't frozen a large rock into a block of ice to test how tightly the ice binds to the rock? When this happens in nature, it results in one type of glacial erosion known as plucking.
Plucking happens when water invades cracks in the rock. As the water turns to ice, it binds onto the blocks of rock.
The motion of the glacier plucks the blocks of rock out of the cliff face, embedding them in the moving mass of ice and transporting them downslope.
Rocks frozen into the base and sides of the glacier act like sandpaper, scraping against the surrounding valley walls and floor, and a second process of glacial erosion known as abrasion.
Abrasion leaves behind telltale striations in the bedrock that identify the direction of the motion of the ancient glaciers.
Some striations, like these grooves worn into this limestone bedrock, can be very deep, indicating that they were formed below thick, powerful ice sheets.
The combination of plucking and abrasion deepens and widens V-shaped stream valleys to produce a U-shaped profile characterized by a flat valley bottom and steep sides.
Much like this example from Scotland, and this U-shaped valley from the Beartooth Mountains in Montana.
If rising sea levels were to flood one of these things, we would have to call it a fjord.
Up to now, we've been focusing on processes that cause erosion. Now we want to turn our attention to features formed when glaciers deposit material near their terminus.
Most deposits left behind by glaciers are composed of a generally unsorted mixture of clay, silt, sand, and boulders, known as glacial till.
Ice at the terminus of a glacier will melt and dump piles of till. If the position of the terminus remains stationary for some time, it can leave behind a ridge of unsorted till known as moraine.
Moraines essentially define where the glacier paused, and the position of the moraine that is farthest down the valley, the terminal moraine, indicates how far the glacier extended during its history.
Ice sheets leave behind moraines that can be traced for hundreds of kilometers across multiple states. For example, this shaded relief map of Ohio shows the positions of several moraines stretching across the northwest corner of the state and into neighboring Indiana.
Piles of unsorted glacial till can be trapped by an advancing glacier and shaped into oblong mounds known as drumlins that narrow in the direction of glacial motion.
Behind the moraines, we also find hundreds of small lakes known as kettle lakes.
Kettle lakes form when blocks of ice break off a retreating glacier and are subsequently buried. The ice gradually melts, forming a depression in the glacial sediment known as a kettle. These low areas may then be partially filled to form a lake, just like these kettle lakes in North Dakota.
A feature known as an esker may be formed when till is sorted by streams flowing at the base of the melting glacier.
The sediment deposited within these subglacial streams leaves behind a skinny, sinuous landform.
Likewise, as the glacier melts and its ice turns to water, meltwater streams transport sediment away, depositing some of it in the adjacent outwash plain.
Thick ice sheets can pick up very large rocks, known as erratics, from one location and deposit them elsewhere, sometimes hundreds of kilometers from their source. By matching the geology of the erratic with their source area, we can unravel the direction and distance of motion of the ice that move these wandering boulders.
And that brings us back to our 500-ton friend among the trees in Yellowstone National Park. This boulder of metamorphic gneiss sits on top of volcanic rocks hundreds of millions of years younger in age. And the boulder must have been carried at least 25 kilometers from its source.
Let's finish off with a matching exercise. We will show you pictures of 4 glacial features. Match each one with a term from the provided list. We'll check your answers when you're done.
So, how did you do? We had 2 learning objectives for today's lesson. How confident are you that you could do these things?
This is about the delta. Let's come again. One second, come again. River has been divided into erosional landform on mountains. It will create waterfalls, etc. And on the plains, it has been divided into meander and oxbow lake. Meander, which means it will be in the form of, it will not flow, the river will not flow in the plain manner. It will be in the horizontal way. And then in oxbow lake, it is a small entity separated by meander, that is in the form of ponds, etc. And coming to deposit landform, it will be delta. The landform, the mouth of the river flow into ocean, seas, etc. So the best example is Ganga Brahmaputra river. Next, we will see about landforms. In erosional landforms, there are different types. One is sea cliff and sea caves, sea arch, etc. Coming to sea cliff, the water, that is the sea waves, will hit the hard rock, and then parallel to the sea is known as sea cliffs. Coming to sea caves, when the water hits the rocks, day by day, the force will be made a crack in the rocks, so that it will make a huge, the crack will be made huge, so that it will make a sea caves in the it will make sea caves. Next, coming to sea arch, there will be increase in the sea as well as outline leaving the roof of the original log. It is known as sea cliff. Now we have seen about the erosional landform, that is the 3 types: sea cliffs, sea caves and sea arch. Next, we're going to see about the deposit landform, that is beach. As we all know, there is a beach has been found on the combination of rivers, oceans, etc. and it will be in the smaller times. And coming to how wind has been acts as a medium of agent, which means mushroom rock. As we also all know that mushroom rock will be narrow and the rock will be in bigger size. This mushroom rock will occurs due to the wind erosions. That is, the lighter particle of the molecules will be carried out so that easily deposit in the form of mushroom rock. The best example is mushroom rock. Next one is deposited landform. Sand dunes. In coming to sand dunes, the smaller particles will be carried out by the light and through the means of wind and water and deposit like a small cave-like structure, which consists of rocks, grains, and other molecules in it, and all the molecules will be present in a small cave-like structure. So it is known as sand dunes. Next, coming to looses, fine like grains. The fine line grains will be travel for long distance so that it will deposit in the large area is known as looses. This is some of the wind carrying agents. Now we can recall from the first, that is coming from the first river has been we are now in today's class we have seen about exogenic process, right? In exogenic process, these are the things comes under, that is the happening which has been occurring outside the earth's surface is known as exogenic process. So coming to river, in erosional landform on mountain, that is waterfall. The water how does the waterfall occurs? A waterfall has been occurs through the means of the formation of rivers. It will be in the form of based on the height they will flow. Next, on the plains, there is two types. One is meander and oxbow lake. Coming to meander, the river will not flow in a plain manner, whereas they will form like an horizontal way, as well as it is similar to a snake. Next, oxbow lake, which means has been separated from meander and forms a pond-like structure, so it is known as oxbow lake. Coming to deposit landform, that is the one thing is major thing is the delta. Landform, the mouth of the river flow into the oceans and seas, etc., is known as delta. Next, we are going to see about the landform. In landform, there is erosional landform. In erosional landform, there are different types. One is sea cliffs, sea arch, and sea caves. These are the things which comes under the erosional landforms. And deposited landforms, that is in the form of beach. Next, wind as a medium of exchange of which acts as an agent. So that there are some of the examples are mushroom rock, and coming to deposited landform, that is sand dunes, and looses, which means fine like grains, long distance and deposit in the large area is known as looses. Yes, the assignment for today is that label these parts. Thank you.